Hello guys, welcome back to our YouTube channel. My name is 𝗍𝗲 and today we are going to solve the problems from the CodeChef Starters 164 from Division 3. This is the first problem. Let us go through the question. Okay, so there are two people in this question, 𝗏 and 𝗏. Both of them are the members of the Shastra's CNL team this year. Okay, so they are having equal programming skills. Okay, but there is one difference, is that 𝗏 height and 𝗏 height are not equal. 𝗏's height is like k and Varun height is like p. Something like, let's assume Ved height is like 5 feet, whereas Varun height is 6 feet. Both the heights of Varun and Ved are differ. Oh, okay. So both want to watch a movie in OAT from outside his gate. Let's say there is a movie is happening, but they did not got the tickets to watch the movie. So they want to watch the movie from outside the gate. And outside of the gate, there are few number of chairs. Okay. So outside the gate, there are n chairs available. Okay. There are n chairs available. So you know the height of the Ved, you know the height of the Varun. Then using these chairs, can you stack one chair on top of another? Can you stack one chair on top of another and sit on this top of these stacked chairs, and can you watch the movie? Yes, you can watch the movie, but there is a condition here, is that so you will be given n number of chairs. Okay, so here you will be given n number of chairs. From this n number of chairs, Ved will get only one chair, and that one chair is the maximum height of the chair. Let's say outside of the gate there is a chair which is of 1 feet, and there is another chair which is of 2 feet, and there is of another chair which is 4 feet. Okay, out of these three chairs, Ved will only get one chair. That is the maximum number, the number which has the maximum height. Okay, so here 4 is having the maximum among all the values, so Ved will get only the 4 feet chair. Okay, but what about Varun? Varun will get all the chairs except the maximum chair. Maximum chair. Okay, so in this case Varun will get 1 feet chair and 2 feet chair. So depending on the given chairs, Ved will get only one chair and Varun will get all the chairs except the maximum height chair, right? So using this, can who which like among Ved and Varun, which person is going to watch the movie clearly is what you need to print. If Varun is able to watch, sorry, if Ved is able to watch by stacking up that chair and sitting on top of the chair, if Ved is able to watch that movie clearly, then Varun, you need to simply print Ved as your answer, or else you need to simply print Varun as your answer. Okay. But what if both of them are equal? The chair size plus Varun height is equal to the chair size plus Ved size. If both of them are equal, then you need to simply print equal as your answer. Let us go through a few test cases so that you will understand. But before going, see the constraints. This is the constraints. You will be given t number of test cases. The n size is very less, n is 100, which means even the brute force solution will work, and k and p are less than or equal to 10 to the power of 4. Okay, so let us see here. Let us see the first test case. So in the first test case, there are the first value is n. N is nothing but number of chairs available outside the gate. So there is one chair, there is third chair. Like first chair is of 1 feet, second chair is of 3 feet. Okay, and what is the height of the Ved? Ved height is 4. What about Varun? Varun height is 2. So now what is the one chair that is going to get for Ved among these two chairs? Only the one which is having the maximum value. Then what is the maximum value? We have 3, right? So Ved will get a chair which has a height of 3 feet. Okay, what about Varun? If you exclude the maximum chair, then there is only one chair which is remaining, which is this one, which is having a height of 1 feet. So now tell me, which person is going to watch the movie clearly? So if you see here, Ved will place the chair on the floor, which is which will give him 3 feet height from the ground level, and his height is 4 feet, right? So if he stood top on this chair, it will add up more 4 feet. So what is 3 plus 4? Which is nothing but 7, right? So Ved is 7 feet top from the ground. Okay. Then what about for Varun? So Varun height is only 2. Okay, first he will place the chair, which will give him one height from the ground. And from the top of the chair, his height is only 2. Okay, so what is 1 plus 2? It is nothing but 3. So which person is going to watch the movie clearly? The Ved or the Varun? Obviously here the Ved. The person Ved is going to watch the movie very clearly. So you need to simply print Ved as your answer. Okay. Now let us go for the second test case so that you can understand it more clearly. So here Ved height is 10 and Varun height is 6. So what is the one chair that Ved can get here? The chair which has a 8 feet. And what about the chairs that Varun can get here? He will get all the remaining chairs, which is nothing but 6 plus 1 plus 4 plus 5 and plus 7, right? So what is the total height that Ved can see from the ground to his eyes? So he can see somewhere like 18 feet from the ground. Then what about for Varun? Let's do the calculation. 6 plus 1 is 10, 14, sorry 11, 16, 23. This is total adding a height of 23, right? So what is 23 plus 6? Anyway, it is greater than 18 feet. So I will simply print Varun as my answer, right? So for the second test case, your answer is Varun. Now let us see the last test case. Anyway, you can see into the third test case. So for the last test case, you have three chairs, which is 1, 1 and 4. And Ved height is 2, Varun height is 4. So what is the one chair that Ved can get here? 4 chair, like a chair which has height of 4. What about Varun? The rest of the chairs, which is nothing but 2. So 4 plus 2 is nothing but 6. 4 plus 2 is nothing but 6. Since both of them are equal, we are simply printing equal as our answer. So this is the overall question. Now how do we solve this? It is pretty much simple, right? So you have all the chairs, simply sort all the chairs, and where do you find the maximum chair that Ved can get here? The last element of the sorted array, right? That is the chair which has the maximum height. Simply that one plus Ved height, compare the rest of the sum. Now let us try to code it up. Okay. So first we need to take the test cases. So int test cases, cin test case, while test case. Okay. Now we need to take the size. Next value is k. K is nothing but Ved, and then Varun height. Okay. Take the input for Ved, then Varun. Okay. Now what is the next step? You need to take the collection of chairs. Let us call it of heights, because each height denotes the height of the ith chair. Okay. Heights of size and simply iterate the entire array. Heights of scene, heights of I. Okay. Now what is the next step? So we know that when you sort the heights, the last chair is going to belong to only Ved, right? And the rest of the chairs is going to belong to Varun. So simply sort the heights comma heights plus n. Now we have the sorted data. What you need to do? First, you need to create a variable max height chair. So this max height, the chair which has the maximum height, is going to belong to only Ved. Okay, we have done that. Next, let us maintain int sum equal to 0. Now let's find the sum of all the elements except the maximum element. So I will simply iterate till n minus 1. From here, sum plus equal to heights of I. Okay, so what is the next step now? So from here, you will simply write some conditions. Is that the current height of Ved plus the maximum shade that he got is greater than Varun height plus all the shades combined. If this is true, then what should I do? Simply print Ved as my answer. If this is not true, then what is the next condition? If Ved height plus maximum shade is equal to Varun height plus rest of the shades. If this is true, then simply print equal. If this is also not true, then simply print Varun. That's it. Ved, Varun, Ved and equal. So our sample test case is passed. So our code got submitted. Thank you for watching the video, guys. See you in the next question. Hello guys, welcome back to our YouTube channel. My name is Dheeraj and today we are going to solve the second problem from the CodeChef Starters 164 from Division 3. Okay, so the problem name is swap and flip. So the question is pretty much simple. You are given two strings, one is S and one is T. Both of them are having equal length. Okay, you are given two strings which are having equal length. You need to simply transform the string S to string T. If this is possible, then you need to simply print yes as your answer. If this is not possible, then you need to simply print no as your answer. Okay, but you can transform the given string to the t string only with the help of two conditions. Okay, so the condition one is you have to select two indices. Okay, two indices, one is I and one is j. So you need to simply swap these two characters from the S string. Okay, you need to simply swap S of I comma S of j. Okay, and again I should not be equal to j. So this is the first operation that you can perform. The second operation is you can select index I and index j. You can toggle the S of I and S of j values, which means here the string is of binary, right? Which is nothing but you will contain only zeros and ones. So let's say in S of I, you are having a value of 0 and in S of j you are having a value of 1. Then if you perform the second operation at the ith index, the value of 0 is going the value of the ith index is going to change. Here it is 0, it becomes 1, and here it is 1, it becomes 0. Okay, this is the meaning of toggle. Okay, so this is the overall question. You are given string s, you need to simply convert the string s to string t. If it is possible, print s. If it is not possible, print no, using only these two conditions. Okay, these two operations. Okay, so this is the input format and output format that I have already explained, and the test cases are only 100 and in value is also very small. Even if you come up with any proper brute force solution, it will work. Okay, now let us see the question. Like, let us see the sample test case. So the first test case is having a length of 2, right? So the first test case is having a length of 2. The first string S contains 0 0 and T contains 1 1. So this is S and this is T. So can you make them equal? So think of this in different way. Okay, so in the S you have only two values, which means nothing but this is I and this is J, assume. Okay, now can you perform swap operation on this? Can you perform swap operation? There is no meaning of performing swap operation on this, right? Because both the characters are same, both the bits are same. It is 0 and it is 0. If you swap them also, you will get 0 and 0 only, right? So there is no meaning of swapping over there. So swapping will not work here. Can I toggle it? If you toggle, this becomes 1 and this becomes 1, hence s is equal to t. So if that is the case, you have simply print s as your answer. Okay, so this is the first test case. Now let us see the second one. Second one is also of same length, which is 2. So you are having 0 0 and the transformed string is having 0 and 1. Okay, so can I swap these two values? No, because even if you swap, the string remains the same. There is no impact on it. So the swap operation is invalid here. Can I toggle it? If you toggle it, since there are only two values, if you toggle it, it will become 1 and it will become 1. hence it is not equal. And if you perform any other operation on this again, it will never be equal to the second string, right? Because there are only two characters. So this is not going to work. What about for the third test case? Since 0 is equal to 0, we will simply print S as our answer, and for this, no. Okay. Now this one. So you are having a length of 4, 0, 0, 1, 0, 1, 1, 0, 1. Focus on this. How do we transform string S to string T? So I can do one thing, is that I will select this as my I and this as my J. I will simply make this to 1 and I will simply make this to 1, which is nothing but I performed toggle operation, right? Now here I have 1 and 0. Can I simply swap them? Yes, you can simply swap them. So this becomes 0 and this becomes 1. Now S is equal to T, so I will simply return yes as my answer. Okay, but there is one key observation on this, is that, so look at this, 0, 0, 1, 0, 1, 1, 0, 1. Previously, what we did in these two indices, we simply performed, one second. So in this, so in these two indices, what operation did we perform? We simply performed toggle operation, which is second operation. In these two indices, what operation did we perform? Swap operation, right? Now look at this. Let's say we have two values, S of I and S of j. So S of I is having a value of 0, S of j is having a value of 0. If the two values are same, will you perform swap operation? Will you perform the swap operation? No, you will never perform a swap operation on the same values. Why? Even if you swap them, the string remains the same, it's same, right? So there is no going forward of transforming the string S to string T. Like there is no impact on it. So you don't simply swap if the two values are same. Now what about this? If S of I is equal to 1 and S of j is equal to 1, will you perform the swap operation? No. Again the answer is same. The string remains the same if you perform swap as well. Okay. Now let me ask you the another question. If S of I is 0 and S of j is 1. Now by swapping, will there be any impact? Like will there be any change in the overall string? Yes, there will be change, because at S of I you will get a value of 1 and at S of j you are getting a value of 0. But the question is, do you really need swap here? The question is, do you really need a swap here? So if you swap, what will happen? S of I you will get 1 and S of j you will get 0. You can get these values done with the help of toggle as well. You can get these values with the help of toggle as well, the second operation. So can I say, in the process of transforming the string S to string T, I don't really need the swap operation at all. I don't even use the swap operation at all, because if both the values are same, I will never do swap. That is the first condition. If the both values are different, I can get the value done with the help of toggle function instead of swap, right? You understood this point? Okay. Now, now here, look at this. Now let us take a test case. Let us take few test cases. Let's say we have a string something like this: 1, 0, 1, 0, 1, 0, 0, 1, 0, 1, 0, and 1. So what is the overall question? You can only select two characters, like two indices, and simply perform the operation. So now we have discussed we don't really use swap, so simply forget that. We will simply use only one operation, which is toggle. So you can select only two values, right? So if these two are not equal and these four characters are equal, can I say that S is not equal to T? Right, because these two characters are not equal to the transformed string. So every character should match with the transformed string. So what I will do means, I will simply select the first two indices and I will check in the transformed indices, like, are they same? No, because here we are having 1 and here we are having 0. Here we are having a 0, here we are having a 1. So what I will do, I will perform the operation. Which operation? The toggle operation. Okay, so I will simply make this to 1 second. I will simply make this to 0. I will simply make this to 1. So this part of the string is sorted, right? Now next I will simply select these two characters, these two pair. Okay. Now here, are they matching? No, they are not matching. Here we have 1. Here we are having a 0. So I will simply toggle them, and the same thing for this one as well. So I will simply toggle them. This becomes 0 and this becomes 1. Now is the overall string equal? Yes, S is transformed to the T string. So here how many times did we perform the toggle operation? For this we performed 1. For this we performed 2. For this we performed 3. For this 4, 5 and 6. In total we have performed 6 operations. Hence we are able to transform the given string from S to T. Okay. Now let me change the test case a little bit. Okay. Now you will understand the overall logic. Okay, let's say we have 1, 0, 1, 0 and 1. T is nothing but 0, 1, 0, 1 and 0. Okay, so now look at this. So I will simply do the same process again. I will select the first pair. They are not equal. I will transform them. This to 0, this to 1. I will select this pair. I will transform. I will toggle. This becomes 0 and this becomes 1. Now we are left with one unmatched pair. This 1, 0. They are not equal. So can I make them equal? No, you cannot make this single pair alone, right? You have to, if this is I, you need to select the jth index from somewhere else. So in this case, what shall we do? The only answer is no, you cannot do anything. You cannot transform this string from S to T. So your answer for this test case is no. So what did you observe here? So what did you observe? Here, how many mismatch pairs are there? Here we got 6. What about here? We got 5. So does this ring any bells? Or let's take one more simple example. Let's say 1 0 0 0 0 0 0. Okay. So you have one different pair which is 1, 0. But what will you do with this? You need, if this is I, you need to select some other pair also, right? There is no other option. Here you have one different pair which is only 1. So I hope you got the logic by now. Is that if S of I is not equal to S of j, you will simply count the number of pairs which accepts this condition, which accepts this condition. Okay. And if this count is an odd number, which means your answer is no. If this count is an even number, which means your answer is yes. Okay. Because for each pair you will do one operation to make them equal. Okay, but if there is only one pair, like if you have odd number of pairs, then the last pair is not going to match with any other pair, so it is left alone. Okay, so this is the overall logic. Now let us try to code it up. So what is the first one is, you need to take the number of test cases. So run the while loop, then both the string length are same, so you will take only one. Now string s comma t, c in s, c in t. So for loop, simply iterate on the given string I less than n I plus plus. Now what you need to do, you need to count the number of different pairs. S of I is not equal to S of j. So I will declare a variable different chars. Okay, or let's call it as different bits, because since we are dealing with bits, if S of I is not equal to T of I, simply increment the diff bits by 1. Okay, now what is the condition here? If the diff bits and 1, if you have odd number of bits, or let's say if you have even number of bits, you will simply print s as your answer, or else you will simply print no as your answer. That's it. Now let's run the code. Yes, no, yes, yes is our answer. Yes, no, yes, yes. Sample test case is getting passed. Correct answer. Thank you for watching the video, guys. See you in the next question. Third problem from the CodeChef Starters 164 from division 3. So the question name is construct permutation. Okay, so let us see the question. So you are given an integer n. Okay, you are given an integer n. You need to simply create an array of size n or a permutation from only the values from 1 to n. Okay, so let's say if I give you n value as 6, then you need to simply create an array of size 6 with values of 1 to 6. Each value is occurring only once because that is what a permutation is, right? So from A1 to A6, you need to simply fill these values. Okay, so in this permutation, this array should be in such a way that whatever subarray sum that I take should not be divisible by n plus 1. Okay, whatever the subarray that I take, the subarray sum that I take from the generated array, the sum of it should not be divisible by n plus 1. The remainder should always be not equal to 0. Okay, so this is the type of the array that you should generate if it is possible only. Let's say if it is not possible to generate an array where every subarray sum is not equal to 0, if that is the case, then you need to simply print -1 as your answer. But if it is possible, then you need to simply print. Okay, let's see what he is asking us to print. Okay, then you need to simply print the generated array. Okay, so the input format will be, you will be given test cases. For each test case, you will only be given the n value, which is the size of the array that you need to generate. Okay, so let us see the examples. So the first test case is having a value of 1, which is, this value is nothing but n, right? So since there is only one value, so I will simply print 1 as my answer, because 1 modulo 1 plus 1 is nothing but 2 will give you the remainder as 1. Hence it is not equal to 0. So you will simply print 1 as your answer. Now what about for the second test case? So if the n value is 2, which means you need to generate an array of size 2, and in this array of size 2 you should contain the values of 1 comma 2 only. So you will be having two permutations, 1 comma 2 or 2 comma 1. So what will be the n plus 1 value? Let us call the n plus 1 value as x. So here it is 3. So if I take the entire array sum, which will be equal to 3, 3 modulo x is always equal to 0. The same thing here as well. So one of the subarray, like considering the entire array is also a subarray. So one of the subarray is getting a modulo of equal to 0. Since there is no way, it's like there is no answer for it. So I will simply print -1 as my answer. Okay. What about for the third one? So if you see here for the third one, if you see for the third test case, which is having a value of n, so the output is 1 2 3. Let's see how. 1 2 and 3. Here x plus 1 is 4, right? So let us take only the subarray, which is having a value of 1. What modulo 4 is 1 only. 1 plus 2 modulo 4 is nothing but 3. So 3 plus 2 plus 1 is nothing but 6. 6 modulo 4 is 2. Hence all the subarrays starting from the 0th index is not giving you any remainder of 0. Okay, let us see for the second one. 2 2 alone is less than 4, hence that remainder is 2. 2 plus 3 is 5. 4 modulo 5 is 1. All the subarrays starting from the first index is not giving you any remainder of 0, and 3 is less than 4, hence your answer is 1 2 3, right? So this is the sample input and output test cases. So how do we come up with a problem for this? Like how do we come up with a logic for this, where every subarray sum should not be equal to x? Here in this case is nothing but n plus 1. Okay, so let us try to have some uh, cases here. Okay, first one, what you need to understand is n value, you will be given only n value, right? This n value either can be even or either it can be a odd. Okay, if it is even, my answer will be for sure -1. Why? Because if you see here, n into, if you are given an n value, okay, let's say n value is 6, okay, so you need to generate an array of size 6. In the array you will be having each index a unique value, which is nothing but at the end of the day you will be having 1 2 3 4 5 6 in your array. What is the sum of this array? It is nothing but sum of n natural numbers, right? So can I simply say, if you are having an n value, so it will be nothing but n into n plus 1 by 2, right? So if you do simplify this, the n square divided by 2 plus 1, it will be, you will be getting n square plus 1, right? Which will be always divisible by n plus 1, right? So for even case, your answer will always be -1. If the n value is even, you will always print -1 as your answer, because there will always be a subarray or the entire array whose sum is divisible by n plus 1. Okay, so the only case that we can handle here is the odd length. If the length of the array is odd, if n is odd, then there is a way to handle that. So what do you think that way is? So everyone look at this. Let's say we have few numbers a1, a2, a3, a4, a5, a6. Okay, let's say we have six numbers. Okay, let's say I generated is prefix sum from a1 to a3. Okay, let us call it as x, and I generated a prefix sum from a1 to a5. Let us call it as y. Okay, so what will be the answer? X modulo n plus 1. Let us assume that we got a remainder as b. Okay, let's assume a b value. Now if you got y modulo n plus 1 is also b, what does that indicate? What does that indicate? It clearly indicates that this subarray is nothing but you are getting a modulo of 0. How is that? Because if you see here, you are getting y modulo of n plus 1 is equal to b, which means, so if you see here, when you do the prefix sum from the a1 to a3, you are getting a value sum as x, and if you do the same sum from a1 to a5, you are getting the sum value as y, right? So x modulo of n plus 1, let's assume you got a remainder of b. Then y modulo of n plus 1, also you are getting the same remainder as b, which means, does this b is always indicating that you got this remainder b only from this subarray, which is from a4 to a5, by removing this x part? No, right? Because this remainder b can be carried forward from the prefix sum, from the previous prefix sum, right? So these values might got a remainder of 0. So how do we handle this case? Which means, for so how do we handle this case? For every prefix subarray sum modulo of n plus 1 should not be equal to 0. So how do we handle that? So think of the test case. Let's assume, take a n value as some 6, or let's take the n value as some 5 or 7, and see, is there a way to generate the values in parallelly in the linear way, so that for every subarray you will not be getting the remainder as n plus 1. So there is a way actually. Let's take n value as, let's take n value as 7. Okay, let's take n value as 7. Now let's assume if I give you n value as 4, and I tell you to arrange 4 elements in the following way, what you will do? 1 uh, 4 2 3. How will you generate this? You will simply make p1 at 0 and p2 at n, and then you will simply print these two values, right? If the sample input and output is looking something like this, you will simply print in that way. So how did you come up with this logic? So the simple thing is observations. You will simply make what kind of pattern is building over there. The same thing you will do here. is there a way, like is there a pattern where for every subarray you will not be getting a remainder of n plus 1 equal to 0? So if you keep on doing trial and error method, you will see a pattern. That pattern is nothing but, so the same two-pointed pattern. So first one is, you will p1, you will start the permutation from the least value, and the least value here is 1, right? And the most value here it is 7, right? For our assumption, if you see here, if I put 7, okay, so what I will do means I will simply place two values, since I need to print 7 values here: a1, a2, a3, a4, a5, a6, a7. So I need to simply print 7 values, right? So I have put my p1 equal to 1 and I have put my p2 equal to 7. So I will simply print 1 and 7. Does this lead to my answer if I put 1 and 7? No, right? Because if you consider this one subarray alone, which is having a sum of 8, then 8 modulo of n plus 1, 7 plus 1 is nothing but 8, you will be getting a value of 0. Hence, in the first iteration itself, you are getting the wrong value. So how do we correct it? So there are two ways. So one thing I will do is, I will start my p2 from the 6. Okay, I will start my p2 from the 6. Okay, so here I will place the value as 6. So for this subarray, you will be getting a value of 7. 7 is less than 8. So now you will move forward. So now your p1, should it be starting from the 2? But I will start it from the 3. Okay, so this will be, p1 will be starting from the 3 and p2 will be starting from the 4. Now if I do this again, 3 and 4, what is this subarray sum? 4 plus 3 is nothing but 7. 7 is less than 8. But you should not only consider this subarray, right? When you build, you also need to consider the whole subarray, like whole array along with this subarray as well. So first let us see this. What is 6 plus 4? 10. 10 plus 3 is 13. Since 13 is modulo 8 is, you will be getting some remainder because 13 is not a multiple of 8. Okay. Now let us take another subarray. You will be getting 14. So 8 times 2 is 14. Then 8 times 2 is 16. Then 16 modulo 4 is, you will be getting a remainder of 2. So till here I got our answer as, like, every subarray is not equal to modulo of n plus 1 is equal to 0. Every subarray is not equal to 0 for every of n plus 1 modulo 2. Okay, now I will simply increment this by 2 and I will simply decrement this by 2. So my answer is 5, 2, and I left with only one value, which is 7. So if I generate like this, what did you observe? There is not even a single subarray whose sum is modulo of n plus 1 is not equal to 0, whose modulo of n plus 1 is not equal to 0. So if you ask me why this is working, it is simple observation and trial and error method. If you see here, a1 plus a2 is always giving me a value of 7. a1 plus a2 is always giving me a value of less than 7. Sorry, less than 8. And here you are left with only one value, which is having a value of less than 7. And if you consider a 3-length subarray, it will always give you the value which is greater than 8 and less than the multiple of 8, like, which is less than 16. And if you keep on increasing the subarray size, it will always give you greater than 16 and less than the next of its multiple. Okay, so in this way, for every subarray you will not found any zero remainder of n plus 1. Okay, so this is the observation. Now let's try to code it up, since it is pretty much straightforward. So let us try to code it up. Okay, so the first one is, you need to take the number of test cases. Then for each test case, you need to simply take the value of n. So what is the first case? If n is even, then there will be no way that you can construct a permutation whose subarray sum is modulo of n plus 1 is equal to 0, not equal to 0. Okay, so if this is the case, then you will simply print -1 as your answer. If this is not the case, then as we discussed, you will assign p1 with the minimum value and p2 with the maximum -1 value, and you will maintain a count variable. I will tell you. So this count variable is for just printing the n numbers. Okay, not more than n. So first one is, you will directly print p1. and then we will increment the count. So here, if the count is still less than n, then simply print p2. Okay, and then increment the count. After this, increment the p1 by 2, decrement the p1 by 2. After the else, cout, or 1 second, here itself, cout and done. That's it. Now let's run the code. The output that we are expecting is 1 minus 1, 1, 2, 3 minus 1, right? Sample test cases are getting passed. Our code got submitted. Thank you for watching, guys. See you in the next video.